Hi everyone. So today we're going to look at the next part of trig integrals, and that's integrals involving tan and sec. Okay, but before we get into that, I just want to do a little summary of what we did last time. So in the last lecture, we looked at integrals that looked like this. So we had sine to some power times cos to some power, and we wanted to evaluate those integrals. So we looked at the three cases that we could deal with. Number one was if the power of cos was odd. So if cos had an odd power, we factored out one of the cos x terms. We changed everything else to sine, and then we used the u substitution, u equals sine x. And then we could evaluate that. If the power of sine was odd, then we would factor out a sine, change everything else to cos, and then use the substitution u equals cos x. Okay, that was the second case. And just by the way, if both powers are odd, then of course you can use either of these methods, they'll work. Okay, so if cos is odd and sine is odd, you pick one or two, it doesn't matter. Okay, and we looked at the last case if both powers were even, and we saw that if sine had an even power, like sine squared, we could change it to something involving cos. Remember, sine comes with the minus sign, and cos comes with the plus sign. Okay, and then we also saw this other helpful identity, sine x times cos x is 1/2 sine 2x. Okay, so that's if both powers are even. Okay. Now we're going to look at the integrals involving tan and sec. Okay, so firstly, let's just write down the identity involving tan and sec. That will be very useful for these integrals. So we start off with the fact that sine squared x plus cos squared x is equal to 1. Okay, that's pretty standard. We know that already. What I'm going to do now is divide the left-hand side and the right-hand side by cos squared. So we're going to end up with sine squared x over cos squared x plus cos squared x over cos squared x is equal to 1 over cos squared x. Okay, now sine squared over cos squared, that's tan squared. Cos squared over cos squared, that's 1, and 1 over cos squared, that's sec squared x. Okay, so this is the identity that we're going to use to go between tan and sec. Remember, we used this first identity, the sine squared plus cos squared equals 1, to change from sine to cos or from cos to sine. We're going to use this one now to change from tan to sec or from sec to tan. Okay. So that's the identity taken care of. Next, we need to find the derivatives of tan and sec. Okay, that's for the u substitution part. Okay, so d by dx of tan. Okay, so if we let u be tan x, we need to find the derivative. What do we get in this case? What's the derivative of tan? Yeah, anyone? Yeah, 2 bonus marks to whoever can answer it. Okay, time's up. It's going to be sec squared. Okay, so the derivative of tan is going to give us sec squared x. And the other thing we need to do is if we're taking the derivative of sec x, what do we get in that case? Okay, so this is going to be sec x tan x. Okay, so please remember these. They're not going to be given in the test, so you need to know them. Okay, and you don't want to have to waste time looking these up. You want to get through these questions quickly. Okay, so these are the three things that we need to know. So we need to know the identity to go between tan and sec. We need to know the derivative of tan in case we make that substitution. And we need to know the derivative of sec in case we need to make that substitution. Okay, so please go over these three things. Okay, so let's take a look at the first example. Okay, so number one, we have the integral of tan to the 6x sec to the 4x dx. Okay, we want to try to figure this out. Okay, so what we can do is notice that the power of sec is even. Okay, we've got sec to the 4. So if we factor out one of those sec squareds, so we can write this as the integral tan to the 6x times sec squared x times, and then we factor that out like that. What we can do is rewrite the sec squared in terms of tan, and then make the u substitution of tan x, because then the derivative would be sec squared, which is what we've got on this outside. So let's rewrite this, the sec squared in terms of tan. So that would be 1 plus tan squared x. Okay, I'm going to substitute that there. So this is going to give us this is going to give us the integral tan squared x, 1 plus tan squared x. And then on the outside, we have the sec squared x dx. Okay, so this tells us that we should do a u substitution with u equals tan x. So we do that. So if u is equal to tan x, then du will be sec squared x dx, which is what we've got on the side here. Okay, so this is going to become the integral of u squared. Sorry, that's not tan squared, that was tan to the 6. So that's u to the 6, 1 plus u squared, and then the sec squared x dx, this part here, that's just going to become du. So we see we get this nice integral to do. So here we can just use the power rule. So this is going to be the integral of u to the 6 plus u to the 8 du. So if we integrate this, we get 1 over 7 u to the 7 plus 1 over 8 u to the 8. 1 over 9. 1 over 9 u to the 9 plus c. Okay, but we're not done yet. We need to substitute back what we let u be. So u was tan x. We need to put that back. So we get 1 over 7 tan to the 7x plus 1 over 9 tan to the 9 plus c. Okay. Oh, is the screen frozen? Sorry, is the screen still frozen? Can someone just give me a thumbs up if it's working? Oh, it is still frozen. Okay, let me reset that. Okay, how's that? Is it working? Okay, can you see that? Okay, cool, it's back. Okay, sorry about that. It says it froze from step 3. Where was step 3? Okay, that was the U substitution part. Okay, so let's just go over that again. So we separated out the sec squared term. Okay, so we separated that part out, which tells us that we need to turn everything else into tan and then do the U substitution, U equals tan x. So the sec squared, we change to 1 plus tan squared, and then we change all of that into U. So tan to the 6x becomes U to the 6, tan squared becomes U squared, and sec squared x dx, that just becomes du. Okay, once you've changed everything in terms of U, you just integrate in terms of U, and then we get our answer in terms of U. Then we need to remember to go back to x terms. So the U equals tan x, we put back. Okay, and then that gives us our final answer here. Okay, any questions on this one? Okay, so it's not too bad. Okay, so there's just 2 cases that we need to deal with. Okay, so this was just an introductory example. Let's go through the 2 cases that will help you answer the more general questions. Okay, so what to do? Okay, so number 1 is if the power of sec is even. So what do we do if the power of sec is even? We factor out sec squared. Okay, so that's the first thing we do. Then we change the others to tan. Okay, and since we changed them to tan, that tells us what the U substitution needs to be. So U is equal to tan x. Okay, so that's what we do if the power of sec is even. Okay, the next thing is what happens if the power of tan is odd? Okay, so what happens if that is the case? Okay, if the power of tan is odd, then we need to factor out sec x tan x. Okay, so we factor that out. Then we change everything else into sec. Okay, and then once everything else has been changed to sec, we use the U substitution. U is equal to sec x. Okay, because the derivative of sec x will give us the sec x tan x that we factored out. So this whole part here, that will end up being part of the du term. Okay. Okay, so those are the 2 cases that we need to deal with. The problem is, for the other cases, there's no set method to go through. So let's just make a little note here. For the other cases, there's no clear method. Okay, so that's a bit disappointing that there's no clear method for the other cases. However, given those cases, you can use U substitution might help. or integration by parts. So you would have to check that given the problem. So for example, if you have something like the integral of sec cubed. Okay, so if you have something like this, we see that the power of sec is odd. Now, we only know what to do if the power of sec is even or if the power of tan is odd. So in this case, we have to try something else. And we will see that given this kind of integral, sec cubed, we need to do this using integration by parts. Okay, so that's for this specific example. Okay, and then the other examples, you might have to do something else. So you could do a different kind of U substitution, or you could try integration by parts. But there's no step-by-step guide for that. Okay, so you just need to be careful about these examples over here. Okay. Are there any questions about that? Okay, let's look at another example where we can use this method, and then we will look at the example of sec cubed. Okay, because that's a separate case. Okay, so this is example 2. So we have the integral of tan to the 5x sec to the 7x dx. Okay, now notice tan has an odd power and sec has an odd power. Okay, so what can we do? So let's go back to our guide over here. The first case is when sec is even, so we don't look at that. The second case is when tan is odd. That's what we have. So this thing says, factor out sec x tan x, change everything else to sec, and then use the U substitution, U equals sec x. Okay, so let's do that. So first we need to factor out sec x tan x. So we take out one of the tans, so it would be tan to the 4x. We take out one of the sec, so we end up with sec to the 6x, sec x tan x. Okay, so this is the part that we factored out. Okay, so that's the step 1 done. Step 2 says that we need to change everything else into sec. So that's this term over here. So tan to the 4x, we need to change to sec. Now tan to the 4x is tan squared squared. So let's write it like that. Okay, now tan squared, we can change into something with sec. So remember the trig identity, 1 plus tan squared is sec squared. So that means tan squared can be written as sec squared minus 1. Okay, but all of this is squared. Yeah, and then the third step told us to do the U substitution, U equals sec x. So let's do that. So if U is equal to sec x, then du is going to be sec x tan x dx. Okay, which is good because that's the part we factored out over here. So all of this part becomes du, and everything with sec becomes u. So this is going to be the integral, u squared minus 1, all of that squared, u to the 6, and everything else there becomes du. Okay, so now we've got a pretty simple integral in terms of u to do. Okay, but we've got this u squared minus 1 all squared. That's not bad. We can expand that out. So that would be u squared squared. So that's u to the 4 minus 2u squared plus 1. And we still have the u to the 6 on the outside. Okay, so what we need to do now is distribute this u to the 6 inside. So we have the integral of u to the 10 minus 2u to the 8 plus u to the 6 du. Okay, now we need to integrate. That's easy enough because it's just simple powers. So we're going to get 1 over 11 u to the 11 minus 2 over 9 u to the 9 plus 1 over 7 u to the 7. And don't forget the plus c. But we're not done yet. We still need to put the sec x back. Okay, so we put it back inside where u was. So we're going to get 1 over 11 sec to the 11x minus 2 over 9 sec to the 9 plus 1 over 7 sec to the 7x plus c. Okay, so everything after this bit, so let's just this bit over here, everything going on from there is just the normal power rule kind of stuff. Okay, you just simplify it so you get a polynomial in terms of u and then do your power law. Okay, the only part that you need to focus on is this beginning bit. This beginning bit here, where you need to identify what method you need to use and then follow those 3 steps. So find what needs to be factored out, change the other terms to what they need to be changed to, and make the u substitution. Okay, just those 3 steps. The rest is very simple power rule kind of stuff. Okay, and then don't forget the very last thing you need to do is change everything back into x terms. So we don't want it in terms of u, we want it in terms of x. Okay, any questions on this one? Okay. So again, this is one of the methods that we can actually use. Okay, one of the 2 cases. I'm just going to show you another example here for something that is not part of these cases. In other words, something like sec with an odd power, so sec cubed. Okay, we're going to take a look at that. Okay, so this next one is something that doesn't fit the cases. Okay, so these aren't too difficult. You just need to think a bit more about what you need to do. Okay, so most of the time it's going to be something with integration by parts. Okay, so let's say you have the integral of sec cubed x dx. Okay, this doesn't fit the cases because we have an odd power of sec. Okay, but remember that the sec cubed can be written as sec times sec squared. So we can write this as the integral of sec x times sec squared x dx. Okay, so together it makes sec cubed. But the nice thing about this is that sec squared is easy to integrate because the integral of sec squared is tan. So this part here is easy to integrate. Okay, and remember, if you have 2 parts to your integrand, and one part is easy to differentiate or the other part is easy to integrate, that tells you to use integration by parts. More specifically, this first term we're going to let be u because we're going to have to differentiate that. And the second part here, we said was easy to integrate, so we let that be dv. Okay, so what do we get if we do that? So I'm going to say u is equal to sec x, and I'm going to say dv is equal to sec squared x dx, okay, because it's easy to integrate. Okay, so what's the derivative of sec x? So du is going to be the derivative of sec x, that's sec x tan x. Okay, that looks more complicated than what we started with, but let's carry on and see if we can make any progress. So now we need to integrate this, and we get v is equal to the integral of sec squared, which is tan. Okay, that's not more complicated, so it's looking better, but let's use our integration by parts formula to see if anything simplifies. So the integral of sec cubed x dx is going to be u times v, so sec x times tan x, minus the integral of v du, okay, but notice here for the second integral, the tan x, sec x tan x, this tan x and this tan x, we can combine. Okay, so this becomes sec x tan x minus the integral of tan squared x sec x dx. Okay, so what can we do now? We have tan squared times sec x dx. Okay, so let's go back to our little thing here. So we have here the power of sec is even, we do that. The power of tan is odd, we do this. Okay, so those are the two cases. Let's see if we can use that here. Okay, so that's not really going to help us here. Okay, because we've got an even power of tan and we've got an odd power of sec. Okay, that's not going to help us. However, we've got tan squared. Remember, tan squared can be written in terms of sec squared. So let's do that. So this is going to be sec x tan x minus the integral. How do we write tan squared in terms of sec squared? It's sec squared minus 1. Okay, times sec x dx. Okay, so this is going to be sec x tan x minus the integral of sec cubed x, that's interesting, plus the integral of sec x dx. Okay, so why is this term interesting here? Because our original integral was sec cubed x dx, and now we see that we've got minus the integral of sec cubed x dx. It's very similar to what we did with the integral of e to the x sine x. Remember, we had to do integration by parts twice, and then we took the term over to the other side. So that's what we're going to do here as well. So if we take this minus integral sec cubed x dx to the other side, we end up with 2 times the integral sec cubed x dx. Okay, very similar to the e to the x sine x. This is equal to sec x tan x. Okay, and then the integral of sec. Does anyone remember what that is? Okay. Okay, so the integral of sec, that's going to be plus the natural log of sec x tan x. Okay, I think we went through that when we did the trig integrals. So the integrals with sine and cosine and their reciprocals. Just check back in the lectures, it might be somewhere there. Okay, but we've got this power of 2 here that we need to take across. So finally, the integral of sec cubed x dx is equal to 1/2 sec x tan x plus the natural log of sec x plus tan x. Okay, so you see it's not straightforward like the other cases, but it is doable if you use integration by parts. Okay, and then you get something like this. So this is an example of when it doesn't follow the nice rules that we've had before. Okay, so just be aware, sometimes you will get integrals that don't follow the standard methods, and then you're going to have to think of something else to do. Okay, most of the time, it's just another integration by parts. Okay. Sorry, check. Plus C, yeah, yes, you're right, plus C. Always remember your plus C. Cool, thanks for spotting that. Okay, so that's all the stuff I wanted to do today. Okay, we'll carry on more after that holiday break, but let's get through the homework problems for today. Okay, so homework problems. Okay, so we're going to have number 1 is the integral of sec x dx. Okay, so I used that over here, and I gave you the answer here, but I just want you to prove that. Okay, so do that one. Okay, it's not too bad doing that. Then another one, the integral of tan cubed x dx. Okay, that one's not too bad. Okay, then what else? Okay, number 3, the integral tan squared x cos cubed x dx. Okay, so now we're mixing things around. We're putting tan with cos. And number 4, the integral of tan squared x sec to the 4x dx. Okay, and one more, let's say number 5, the integral of tan x sec cubed x dx. Okay, so a little mix of things here. Okay, so this first one here, that's just proving what we used over here. Okay, so I just put the answer there, but I would like you to work it out separately there. The integral of tan cubed, that's not too bad to do. Okay, and then everything else is all right. Okay, so these 5 homework problems, they will be worth +2 points each. Okay, so that's +2, +2, +2, +2, and +2 as well. Okay, remember, you can do as many as you like, but make sure that you post it on the WhatsApp group, and only the first person that posts the correct solution, so fully correct, they will get the points. Okay, any questions about these homework problems? Okay, And just by the way, tutorial 8, okay, so you were supposed to be going through that for this week. That will be covered during the mid-semester break. Okay, so we finished all the work now for tutorial 8. You have the mid-semester break to go over all of that, just as revision for this trig integral stuff. And then when we get back on the Wednesday, you will write the tutorial, the summative tutorial quiz on trig integrals. Okay, so it will be either 3 short ones, so 5 marks each, or 1 longer one for 15 marks. Okay, we'll check on the group. You guys can decide. Okay, so maybe you want just 1 longer question for 15 marks or 3 smaller questions, 5 marks each. I'll let you decide on that. Okay, and then that's the plan for when we get back after the holiday. Okay, and remember, during the holiday, we're going to have those holiday classes from 10 to 11 every day. And then I highly encourage the people that I sent emails to. So I sent the email with the long list of students. If your student number appears there, please go to those holiday classes. Okay, get some extra help with those topics. And then, we can improve our test 3 marks. Okay, because that's coming up on the 11th of May. Okay, so not too far from now. Okay, as always, if you have any questions, please just WhatsApp me or email me, and I can get back to you as soon as possible. Okay, enjoy your holiday, and I'll see you in those holiday classes. Okay, bye everyone.